What's up, guys? Welcome back to a new video. Today we're gonna be proving. Let me just write it real quick. Proving that a sequence, right, converges. How do we do that? How do we prove this? Well, it's quite simple. First of all, we start off by writing a sequence. So let's say we have a of n, right? 1 over n squared plus 1, right? And now let's write the first few elements, right? So if we take the calculator and you can just input that into the calculator from 1 to up until infinity, we're gonna have that the first element is gonna be one half, and 1/5, then 1/10, 1/17, and 1/26, right? Up until infinity. Now, what can we do with this, right? Like, we know that the limit will converge to a certain thing, but we want to know what, right? In this case, it converges to 0. We already know this because the limit is 0. However, how can we prove this? Well, first of all, if we want to prove that a of n converges, we're gonna first simply gonna find the limit of a of n, right? So as n approaches infinity, what's the limit of n squared plus 1? This is quite self-evident as we have just a denominator over here. So as n grows larger, it'll approach 0. So this means this is 0, right? So we can simply say the following. A is equal to 0. That's like our assumption, so to speak. Let's actually just erase this. Let's put it here. Assumption, right? Assumption here. Assumption. The assumption is that A is equal to 0, right? Now, what are the criteria to actually find the limit of this? Well, quite simply, we have the following, so to speak, definition, right? We have for all epsilon that are greater than 0, right? We have, there exists a number, an n, that is within the natural numbers, such that, right, all n's, all small n's, are greater than n, right? Right? And a of n minus L is lower than this, than epsilon. So what we want to basically prove is this thing here, right? So in this case, we already know what A is in this case, as you can see, but we want to find whether this is satisfied, right? So in this case, we have to remember that, well, where does A come into play? Well, remember that whenever we have a limit, right, from n to, say, I don't know, another value m, right, of any sequence, let's call it A of n. This is going to be A, basically, over here, the limit. So the limit is basically A equals 0, so we can write the limit as here. Over here, L, we can simply take it as, instead of A, because we're going to get confused, we're going to take this as L, right? L is equal to 0, which stands for limit, right? The limit is equal to 0, and this is L. And an minus L has to be lower than E, right? So in this case, we know that A of n, right? We can write here A of n minus 0 in this case has to be lower than E, right? So in this case, we can see easily that we can simply take, hold on, let me just check this out. Yeah, that this is basically A of n, right? So that's pretty much it. Now we can write our actual, so to speak, function, right? And now we want to clear for n. We want to clear for n. So what we do here is we're going to do first 1 over e, which is going to be n squared plus 1, which in this case we're going to have e minus 1, and then square root, right? Square root is going to be n, basically. And this is simply, right, that n, the big N, remember the big N that we earlier defined, is going to be equal to this, right? Now, why is it equal? Well, if we go back to our definition, n is within the natural numbers, yeah? But then n has to be lower than n, right? So in this case, we're saying that this is lower than n, so we can simply say that this is our n. This is basically satisfying this, which is the same as what we have over here, right? Same thing. So now that we have that, we can simply say, hey, well, n is greater than n, right? So we can simply say n is greater than 1 over epsilon minus 1, which translates to, right, a of n minus 0 being lower than epsilon. And that's how we basically showed that the sequence a of n converges when L equals 0, no? That's pretty much it. So now we can take the same thing here. We can do the same thing for another exercise. Let's try it out with this one over here. We have b of n, right? And we have this one, 2n cubed minus 4, 3n minus n squared. Now, obviously, we can simply continue solving this. Okay. We have this sequence. So how do we solve this, right? The first step we want to do is find the limit of this. So find the limit. So n, as n approaches infinity, of this little guy, right? And this is going to be basically just us finding the limit, as we saw in the previous video. So we can do minus 4n. Oops. No, hold on. 4, Then we do here. And here's going to be 3n. That means that we have 3n squared, I think. No, 3 over n. Yeah. And then we have minus 1, right? This cancels out. So we're going to have simply, as it approaches infinity, 2 minus 0, 0 minus 1, so minus 2, right? That's basically going to be it. Oh, hold on, I messed up something up. I'm sorry, guys. I just did a little confusing here. No, we do here instead of, yeah, it's n squared. I just did a mistake here. I'm sorry, I was mistaken. So at the end, we're going to have simply 2n cubed, and then that's some sense. We can have simply n cubed 2 minus 0, right? As it approaches infinity. And then n squared as this minus 1. Then we're going to have 2n cubed over minus n squared, which is simply going to be minus 2n, simply. So that's pretty much the limit of our sequence. And as you can see, the limit of our sequence minus 2n as n approaches infinity is still going to grow to minus infinity. So we can simply say that this is minus infinity, right? So the limit of this is minus infinity. So we can simply say L equals to minus infinity, right? And now we want to take, well, basically, we simply see, now this will just directly nullify the fact that it'll converge. Why? Because we try to find a value that works for this parameters, but it will never work because it's minus infinity. you know? So it's not true. This is as because this is infinity, it's convenient, it doesn't converge. Basically, that's pretty much it. So yeah, I think that covers pretty much the video for this topic. It's really not that hard. So yeah, thanks for watching.